So, in the previous lectures we started with understanding physical work environment, and in that category we discussed about the effect of noise on the human performance. So, we discussed about various factors that are responsible for noise and the fundamentals regarding the sound intensity. So, in continuation with that, we will try to cover in this lecture the noise control and noise factors and effects, the summary of that. So, first of all, noise factors and their effects. So, basically the noise factors of primary concern, the two noise factors of primary concern in the terms of their effects on human workers is that the intensity of the noise and duration of the exposure. As far as other noise factors of interest, this frequency that is perceived by listeners as pitch, and industrial noise is usually broadband composed of wide range of frequencies, so it is important and is diminished. Non-continuous noise, there are intermittent noise, machines with on-off cycle. Impact noise, just like in manufacturing industry, drop forge hammer, and in impulse noise in a gunfire industries. So, these are the some of the examples through which you can have an idea of non-continuous noise, and still it makes a large impact on the workers that are working in the surrounding. As far as physiological effect of noise is concerned, so when a person is exposed to a sudden loud noise, it's like an impact. So, that impulse noise is known as basically the reaction is known as startle response. So, when a person is exposed to sudden loud noise, the reaction is known as startle response, which causes spontaneous muscle contractions or blinking eyes or closing of the eye and head jerk movement. So, that are the reaction when sudden noise comes to you, and your response appears in the form of blinking of eye or sudden eye closing and or your sudden head jerk movement. Other physiological effect that you can experience, like slower and heavier breathing, variation in heartbeat rate, and the dilation of eye pupils. So, this startle response this particular startle response causes distraction and disruption of a person's current activity and although its physiological effects are transient and in a very momentary in nature, it can elicit annoyance and other negative reactions, you can say, or negative emotions as well. So, of particular concern in ergonomics, the hearing loss due to noise is very much important and serious factor. So, like sudden blast happens, and the sound intensity while passing through the auditory channel in your ear, and sudden it may distort, it may damage your eardrum. So, that hearing loss can be categorized into three points. The first point is the temporary threshold shift. It is a hearing impairment of short duration. Noise induced permanent threshold shift. It basically results from long term exposure to noise levels above 90 decibel. And third is acoustic trauma. So, this acoustic trauma is a single exposure to high intensity noise which can cause temporary or permanent hearing loss. So in that case, so abbreviation of these things, like if we could write in a short form, so temporary threshold shift can be written as TTS. This particular noise induced permanent threshold shift can be written as NIPTS, and this particular acoustic trauma can be written as AT. So this is just for pronunciation. So now this particular noise induced permanent threshold shift, that is NIPTS, this is a hearing loss that is not reversible. Full hearing is never recovered. This NIPTS, it results from long-term exposure to noise levels above 90 decibel. So the damage takes place, so the damage mostly takes place in cochlea of inner ear, which contains this cochlea of the inner ear, as we studied. So basically in that this particular damage is in cochlea of the inner cell. This cochlea is having microscopic auditory hair cells, and high intensity noise exposure over the extended period of time destroys these sensory cells. So the net effect, this NIPTS, so the net effect of permanent damage is a threshold shift expressed in, which is expressed in decibels. So NIPTS does not imply complete deafness, it means a reduction in auditory capability. So this particular NIPTS means reduction in auditory capability. So this is not a permanent deafness, it is just a reduction in auditory capability, and amount of hearing loss is depending on the intensity level, and it varies among individuals. The third kind of hearing loss is acoustic trauma. So this is caused by just single exposure to high intensity noise of short duration, and depending on the intensity of the noise, the hearing loss can be temporary or permanent. So now we come to the next topic, that is permissible noise level. This levels, basically one agency is there whose name is OSHA, OSHA, which is meaning its full form is Occupational Safety and Health Administration, which those noise level standards are set by this particular agency, and it is designed to avoid the hearing loss effects that we discussed some time before. So the standards specify the permissible duration of exposure for each of various sound pressure levels using dBA scale. A partial listing of the standards is shown here. So here we can see that there are various sound level values, its duration, sound levels, and its duration. So there are basically this particular table is like that. So here we can see that a continuous sound pressure level of 80 dBA is acceptable and requires no abatement steps. A value of 85 decibel is customarily used as a threshold level at which employees should begin to take action to control the noise. A sound pressure level of 90 decibel must be limited to 8 hours of exposure, and any level above 90 means that noise abatement procedures of some kind are required. So for sound pressure levels that are not given in this particular table, so the permissible duration of exposure for a given sound level can be calculated by, so this particular permissible duration of exposure can be calculated by this one formula, says TPDA 8 upon 2 to the power 0.2 SPL minus 90, where this TPDE is permissible duration of exposure, that is expressed in hour. SPL is the sound pressure level, that is expressed in dBA. So it is not uncommon for a worker to be simultaneously exposed of these sources. Expressed as an equivalent sound pressure level can be obtained by the following equation that I am writing here, that SPL equals to 10 log base 10 summation of I 10 to the power 0.1 times SPL, and this is I. So here we can say that this SPL in, as a total is a total sound pressure level of multiple noise sources. It is total, in fact TOT we can say add here, SPL TOT is total sound pressure level of multiple noise sources, that is expressed in dBA, and this SPL I equals to sound pressure level of noise source I, that is expressed in dBA, where I is subscript to distinguish different sources. So we are going to start with the next topic, that is noise control. So here another common situation is for workers to be exposed to several different noise sources for a different duration throughout a given work day. So combined effect of different sound intensities can be summarized as a noise dose. So another factor that I am giving here as a noise dose, which is nothing but percentage value that combines several several noise components into one measure. Such that any value above 100% exceeds the OSHA permissible limit. So this particular noise dose value that is less than or equal to 100 is acceptable. So in fact this noise dose value can be calculated as if we can write it as a ND, that is 100 summation of T EXJ upon T PDEJ, where this ND is the noise dose, this TXJ is exposure time, this exposure time at a given sound pressure level and like during period has to be defined during some period, let us say J hour, and this TPDAJ is this TPDEJ equals to that is basically permissible duration of exposure at a given sound pressure level. So here it is defined as basically permissible duration of exposure at a given time, at a given sound pressure level in hours. So and the summation is carried out over all period during the shift. So this summation is used for that. So in this way noise dose can be calculated. So now we can now explain this noise control, because the fundamentals has been covered. So now just given the existence of a noise problem in a particular facility, so there are there can be two general approaches which can be pursued to address this problem. So first is administrative control and second is engineering control. So in that so because there are two ways to control in any organization that particular noise level. So if it is some technical faults are there in any system which is responsible for creating noise, so the engineers will take care of that. If it is something beyond technical, so administrative will help in reducing the excessive noise level, thereby creating the ergonomic system. So here the administrative control to avoid hearing damage. So this basically administrative controls are directed at managing the exposure duration for employees working in noisy environment. So administrative control are directed at managing the exposure duration. That exposure duration we can this exposure duration is TEXJ for employees working in noisy environment, by scheduling the exposure time to achieve a total noise dose less than 100%. So the scheduling involves balancing the time spent in noise environment against offsetting times spent in quiet environment. So another form of administrative control involves education and training of workers. which is the training will be about making them aware of the potential hazards of intense noise and importance of using the engineering control that have been installed for noise abatement. So, the importance of administrative noise control must not be minimized. It is generally agreed that more desirable and potentially more effective approach is through engineering control. So, here we can see that noise abatement at 3 locations. We can think of the source, receiver and path between source and receiver. So, as far as this engineering control is concerned, it involves various techniques and ways that can be implemented to reduce the noise intensity level in the work environment. So, basically there are 3 regions where the noise level can be thought of to reduce. So, first at the point of source, second at the region of receiver, and third is the path between the source and receiver. So, in this way, like if this is source and this is the path and this is the receiver. So, source, path, receiver viewpoint in the design of engineering control for noise abatement. So, noise control at the source involves the redesigning of the machine. Redesigning of the machine or process that generates the noise. So, reducing the noise level emanating from the source is usually the most effective approach to abatement, but also it is usually the most difficult and one of the most expensive approach, because the machine installation is a very expensive thing, and if you are thinking to redesign or the system and process, so it will cost too much. So, that is why it is very much expensive approach. So, the machine or process has been designed to accomplish a given function. So, if a noise is coming, it means that noise will also be responsible for wear and tear of that particular machine. Example of inherently noisy machine include like jackhammers, forge hammers, stamping presses, when now noise level is too high. So, it is difficult to design these machines for quicker operation without impairing their productivity. So, in this case it is when the interaction between the tool and workpiece is taking place, and that is the required, like in forging operation in manufacturing. So, that forging, like in the drop forging, when sudden impact is essential to put. So, here the noise will certainly be coming, and you cannot control that noise level at that particular moment of time when the sudden impact is going to put over the workpiece in order to change its dimensions, size or shape with the help of the plastic deformation. So, for that plastic deformation of a particular workpiece, it is essential that you will put an impact over that particular substrate or workpiece which you want to provide a desired size and shape. So, in that noise will come obviously, and it will be ideal job of an engineer if you could reduce, if you could manage that noise level in the particular manufacturing industry, especially for those work which essentially be having some sort of noise. So, so engineering control, we have to think that because as we mentioned that there is a way to control noise on the administrative or engineering level. So, engineering level is much more convenient for utilizing it for noise control in any industry. So, let us take one example. So, before that we covered this particular thing, that source, path and receiver. So, this particular source, path, receiver viewpoint in the design of engineering controls for noise abatement. So, three reasons where noise can be reduced: at the source, at the receiver and along the path of the path between source and receiver. So, there are situations in industry where the noise is compulsorily becoming. So, in that situation the worker is continuously being exposed to that particular noise level. So, what could be the possible remedy in order to provide the better environment to those workers who are directly exposing to that noise level? So, in that context, engineering controls at the receiver means providing some ear protection for the worker who is constantly working in the noisy environment. So, the types of ear protection equipment may include ear plug, may include ear muffs, it may also include helmets. So, this particular ear plug is made up of pliable material that can be fitted into the auditory canal, that is outer ear passage, to reduce the sound that reaches to the middle ear and inner ear mechanism. Ear muffs cover the complete outer ear to reduce noise, and helmet fits over the head and ears, in some cases completely enclosing the head. So, ear plugs and ear muffs are often combined to increase the protection level over either one alone. So, all of these ear protection controls are considered less satisfactory than engineering controls at the source. So, like I am giving you possible engineering controls at the source of noise, like if you target some machines or process and possible engineering control at source. So, if the noise from fan and blowers are coming, so engineering control may be the increase of size of fan or blower, so that it moves the same amount of fluid at lower rotational speed. So, this generally it will reduce noise output. If the sound is coming on the, let us say, vibrating machinery, so we have to provide better balancing of the components. Such noise often results from generally imbalance of rotary or rotating members. Impact equipment, such as stamping or forge hammers used in manufacturing industries. So we have to move the equipment onto rubber mounts to reduce the transmission if possible. So impact noise of this kind of equipment is often partially transmitted through the floor of the plant. So we need to take care of the base or floor of the plant, and so the engineering measures need to implement engineering controls are necessary for any manufacturing industries in order to reduce the noise level. So with this I am closing this lecture, and then as per our culture I am giving you one line to think that if you were an automobile engineer, which type of exhaustion system would you like to have in your design in order to reduce the noise while having an engine with a very high power. So think about that. There is a graffiti for you. Enjoy, and that's all for now. We will be dealing with the climatic control conditions, and that is affecting the work environment in the next lecture. Thank you.